Hello friends, in this video today I'm going to show you how to derive the formula for time dilation. So that means this expression. Let us assume a light clock in the space and an observer also. So this is the light clock, suppose, and here is the source and here is the detector, and it emits light from the source. And here is the observer in the space to observe what's going on in this clock. And here you see he observed that to reach this detector the light takes time delta t naught, and light travels with the speed c. Okay, speed of light is c. We know that distance is equal to speed into time. So that's why this length must be equal to c into delta t naught. Okay, let me use another color. This distance must be c into delta t naught. Now for an observer on earth, here is an observer on earth, and this clock is moving in this direction, suppose with velocity v. Okay, so before this pulse of light reaches the detector, so it moves like this. These are the positions before the light is detected by the detector. These are the positions of the clock, light clock, suppose. So here you see the distance traveled by the light observed by the observer on the earth is this is the distance this observer will observe, okay, when light is detected by the detector. So what we have got, so we have got two distances. This distance you can imagine like this distance c delta t naught was observed by the observer on the space, in the space, and this distance is observed by this observer. So I have drawn the part here inside. So now you see this distance in this case, this distance is observed by this observer on the earth surface, and according to him, suppose time taken is del t. Then as the light is traveling with the speed c, this is c is the speed of light, and time taken is del t. So that's why this distance must be given by c into delta t. So here it is c into delta t. Okay, so I'm drawing the part that is covered by the light in this case only here. Okay, so now you see as this clock is moving with velocity v according to this observer, then what will be this distance? That means this one, from this point to this point, what will be this distance? So again we are going to apply the same formula, that is speed into time. So as it is moving with the speed v in this direction, so v is the speed, and time observed by this person, this observer on the earth surface, is dt. So this is v dt. So now you can assume this is a right angle triangle here. So you can apply Pythagoras theorem. If you apply Pythagoras theorem, then you will get c del t whole square is equal to c del t naught whole square plus v del t whole square. So now what we are going to do is divide both sides by c square, then you will get del t square del t naught square plus v del t by c whole square. Then simplify, you will get del t square minus v del t by c whole square is equal to del t naught square. Then you can take del t square common from these two. If you do so, then what you will get, del t square, so 1 minus v square by c square is equal to del t naught square. So now if you simplify this, let me scroll down the page. If you simplify this, then what you will get, then you will get del t square is equal to del t naught square by 1 minus v square by c square, and taking square root on both sides, you will get del t by del t naught, equal to del t naught by root over 1 minus v square by c square, and this is the required expression for time dilation. So hope you have understood how to derive the equation of time dilation. So I hope it is helpful for you, and if it is, then please share with your friends and do subscribe the channel, help me to grow my channel. And in the next video we are going to discuss about Galilean transformation and Lorentz transformation. Thank you for watching.